Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. For a compound to be meso, it must have stereocenters with opposite configurations that are mirror images of each other, related by an internal symmetry plane. Moving on to the next step. The structure is a tetrahydrofuran, oxolane, ring bearing two stereocenters, each substituted with Br and H. One carbon has H on a dash, going back, and Br on a wedge, coming forward, and the other carbon has Br on a wedge and H on a dash. The two stereocenters are in a cyclic framework. Examining the configurations, if one center is R and the other is S, and the two halves of the molecule are constitutionally identical, both bearing Br and H on the ring carbons of the same heterocyclic ring, there exists an internal mirror plane bisecting the molecule. This makes the molecule a chiral despite having two stereocenters, the definition of a meso compound. Moving on to the next step. In structure A, the two stereocenters each bear two methyl groups and one H. The depicted wedge dash pattern at both centers appears to show the same configuration, both wedge H, both dashed me, making this a pair of like configurations, RR or SS, which would be a chiral compound, not meso. And for the final step. Structure C shows a bicyclic diol, cyclopentane diol. While the two OH groups are on adjacent ring junction carbons with apparently opposite orientations, the ring system is not symmetric enough, the two halves are not mirror images due to the ring connectivity, or the configurations do not produce an internal plane of symmetry. Structure D is a spiro compound with two CH2OH groups on the same carbon of one cyclopentane ring. Having two identical substituents on one carbon means that carbon is not a stereocenter, it's a quaternary carbon with two identical CH2OH groups, and the spirocarbon connecting to cyclopentane rings is also not a stereocenter in the conventional sense. The molecule may have a plane of symmetry, but lacks the two distinct stereocenters required for a meso classification in the traditional sense, or the overall structure does not fit the meso definition. Option B has two stereocenters of opposite configuration, one R, one S, within a symmetric cyclic framework, the tetrahydrofuran ring with identical substitution on both stereocenters, giving it an internal plane of symmetry. It is the meso compound. Therefore, the correct answer is B. Therefore, the correct answer is option B.